Welcome everyone. I'd like to introduce you to the Felix GX emission scan, and we're going to be adding temperature control to the emission scan in a way that we can run an emission at 10 degrees C, and then we want to increment it every 5 degrees up until 80 degrees Celsius. This will give us 14 traces, each one 5 degrees apart. So in order to do this with Felix GX, we want to go into the setup, and from the setup we're going to choose an emission scan. Okay, now that we have emission scan open, we're going to go through the acquisition settings, and we're going to excite at 290. This is a BSA protein that we'll be looking at, and we'll scan from 300 to 450. I'm going to set the step size to 1 nanometer and the integration time to 0.1 second. Next thing that's required is to go over to the temperature control, and we have to enable repeats. So we've got the temperature control enabled by clicking on this checkbox, and I've put in 14 repeats. Right, what we do is we start at a specific temperature, say 10 degrees C, and then we want to increment the temperature by 5 degrees for every repeat. So once I enter these parameters, if I go back to explicit, you'll then see the start temperature will show up as 10 degrees, and we'll be able to scan all the way up till 80 degrees C. Okay, right now I've set the temperature to go to 10 degrees at the end of the scan when the experiment's done, so it will go back. If we want to do a reverse ramp scan, we can leave this at, say, 80 degrees, or we can also select hold at last temperature. From the Traces tab, we'll be generating a trace with this name, and we'll also be able to monitor the temperature. There's a couple of preferences you may wish to set. Always create a new session. I'll check that on. Actually, I'm going to leave it off in this case because we want each trace to go into the same session. Under the Traces tab, we may also want to assign both of these to the same group, so I'll just choose Group A. Now that we've done that, we're ready to start the scan. The temperature I've already prepared and sent it to 10 degrees C. I did this by setting the target to 10 and saying go. Now that the text fonts are blue, that indicates that the temperature is at 10 degrees. So we'll start this acquisition next. Okay, the temperature controller is waiting for a settle time of 30 seconds, and then when 30 seconds is over, the scan should commence. The first scan will be at 10 degrees C. Okay, we've reached 10 degrees, and the temperature controller has then begun scanning. I'm just going to hide this green trace, which is the temperature controller, and we're just going to monitor the scans. Once the scan reaches 450 nanometers, the monochrometers will go back to 300, and the temperature controller will then go to 15 degrees. The rate that I've set it to is 10 degrees per minute. The orange font indicates the temperature controller is ramping, and when it becomes a blue font, then the temperature has reached the designated temperature. I'm going to pause the tutorial, and I'll come back shortly after the scans are finished, so you'll be able to check out all the data. Hi, welcome back to the temperature ramp tutorial. I'd like to show you on the screen here what we have as a result of 14 emission scans at 5 degree increments. As you can see on the screen, we've done 14 different emission scans at 5 degree intervals. In the legend here you can see I've got a temperature for each individual scan. I've chosen to hide all of the temperature ramps and just look at the emission scans, going from 1 to 15. The first scan is the blue one towards the top, and then as we increase the temperature we see a decrease in the overall fluorescence intensity. And there's an interesting trace here, this white one, about halfway through. We can see here by hiding the number of traces before the white one, we can toggle the visibility. You can see that this trace here is clearly different than the rest of them. So obviously there was some form of a conformational change there, and that may be what we are interested in looking at. So that's all there is to doing a emission scan with temperature ramping. I hope you've enjoyed the tutorials, and we hope that you tune in for more tutorials on how to work the Quantum Master instruments, as well as a number of other instruments from Photon Technology. Thanks very much.